Okay. Wave optics topic, weightage for the NEET is 4 marks better. The first reading for this one is we'll talk about your nature of your light. The nature of the light, first point you need to remember that particle nature of the light is being given by particle nature of light. This was being proved or been given by scientists called as of your Newton. Okay. Next one is wave nature of your light. Because light has both dual nature, na beta? Isn't it? Light has both dual nature. So wave nature of the light is being explained by Huygens. So what is the name of the scientist who explained the wave nature of the light? Huygens. Now in this wave nature of the light, we'll be talking about your Young's double slit experiment. Very important. Young's double slit experiment. Double slit experiment. We call it as YDSE. Okay. So this is your experimental proof for the wave nature of your light. This is your experimental proof for wave nature of light. Okay. So wave nature of light proof is been given by scientist Young's, and the experiment given by that one was your Young's double slit experiment. Okay. So this is very important. Young's double slit experiment. Wave nature of light is being given by Huygens, and particle nature of the light was being given by your Newton. Light has both electric nature, what you call particle nature and wave nature. So this is called as a dual nature. Particle nature will be studying in modern physics, photoelectric effect that was been given by the Newton and Einstein. Wave nature of the light is being given by Huygens, and he explained it by the principle called as a what? Young's double slit experiment, YDSE. This is an experimental proof for the wave nature of your light. Okay. And the third one is dual nature of your light. Dual nature of light. Light has both particle nature and wave nature. This was been given by the scientist called as of your Einstein. It was been given by your Einstein. Wave particle, it has been proved both wave and as well as of your particle nature of your light. So both particle nature and wave nature of the light is being given by the scientist what beta? Einstein. By the dual nature, photoelectric effect is being explained by him. A very important topic, but the dual nature. Clear? Sure. Now see, in this topic, wave nature, small topic, we'll be studying first about your Young's double slit experiment. This is your Young's double slit experiment. Young's double slit experiment. Okay. And second one is about your diffraction. Second one is about your diffraction. These two experiments are your proof for your wave nature of light. Proof of your wave nature of your light. So wave nature of light is being proved by the Young's double slit experiment and diffraction. The last topic of this chapter is your polarization. Polarization. This explains your transverse nature of light. Transverse nature of your light. Am I clear, buddy? So total blue picture or blueprint of this chapter is first we'll be studying about your Young's double slit experiment, then we'll be studying the diffraction, and third one is about your polarization. Polarization proves your transverse nature of your light. Okay, whereas your dual nature of the light is being wave nature of the light is being proved by your Young's double slit experiment and as well as of your polarization. Okay, am I clear till this here? So what is a wave optics? A branch of physics which deals with your wave character of your light. That has been given by scientists called as of your Huygens. And in this chapter, we'll be studying about your Young's double slit experiment and as well as of your diffraction and polarization. Done? Sure. Let us try to go for the first reading. Huygens principle. In Huygens principle, the first thing what we need to remember is about your wavefront. It gives me the concept of your wavefront. Can anyone define me what is a wavefront? Wavefront is nothing but what? Locus of all particles. Locus of your all particles which are in same state of vibration. The same state of vibration. Am I clear? That means they are having same phase. They are having right same phase. So what is a wavefront? Locus of all the points which are in the same state of your vibrations. Am I clear? Let's say for example, this is your ray of light like this. So bundle of your rays of lights are going like this. Okay. If I take one particle in this one, like say for example, this is one particle here, this is one particle here, this is one particle, this is one particle, this is one particle. Because light is made up of some billions and trillions of particles. If I take one particle in this one and attach all of them like this, that means if I draw a line exactly touching all of this one, this will be called as of your wavefront. Okay, and this one is called as of your ray of light. This is called as what for me? Your ray of your light. So wavefront is making an angle of your how much for me? 90 degrees with your wavefront. This is very important. Am I clear? So the locus of all the points. What are the locus in this? Can you tell me, beta? What are the locus in this one? This one point. 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 All of them, if I attach it, that line is called as of your wavefront. Am I clear? Am I clear? Even if I take one point here, 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 and attach all of them by a straight line, that will be called as of your wavefront. Am I clear? What do you mean by wavefront? Wavefront is nothing but what for me? Locus of all the particles which are in same state of your vibration, or they are having the same phase. Angle made by the wavefront with the ray of light is how much, beta? 90 degrees. This is very important to be remembered. Angle made by the wavefront with the ray of light is how much for me? 90 degrees. Am I clear with the definition of a wavefront? Am I clear?
Yes, sir.
Sure. And one more point you need to remember in this one, beta. Every point of the wavefront, every point of wavefront behaves like a secondary source. Okay, so every point, this is very important, every point of your wavefront will behave like a secondary source. That means, like say in water, if there is a water, if I drop a stone, you know that vibrations will be going in the form of your circle like this. So one circle will be creating the second one will be creating the third one will be creating the fourth one. So this center one is called as parent. This one is called as of your secondary. This is giving birth to the second one. First one is giving the birth to second one is giving birth to third one, then fourth one, go on like that one. So one is called as what? Secondary wavelength, and center one is called as what? Parent source. Am I clear? So what is telling? Every point of the wavefront, like means this dots, whatever you have taken right now there, the dots are acting as of your what? Secondary source. So from that one also, the ray of light is been going in the form of your spherical forms. Am I clear? Am I clear?
Yes, sir. Yes, sir.
Sure. Response karna beta. Now see if I'm having a point source. If I'm having a point source, okay, just like a candle in a center of your room. So this one is like say point source. The light from the point source will go in all directions like this: front, back, up, down, first quadrant like this, third quadrant like this, fourth quadrant like this, second quadrant like this, all of them. So if I take the locus of the points, if I take one point here, if I take one point here, if I take one point here, 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 and here, if I attach all of them, see what type of wavefront we are getting, better? Spherical wavefront. What type of wavefront we are getting? Spherical wavefront. The point source is giving what type of wavefront? Point source is giving me your spherical wavefront. If someone asks you a point source of light will give what type of wavefront? It will give me your spherical wavefront. Like this will act as of your again another source. It will give me one more wavefront in the output. So it will go on, it will be spreading like this in the form of what? Circle. So if I attach the locus of all the points, that will be giving me the secondary wavefront. Am I clear? Am I clear?
Yes, sir.
Yes, sir.
Any doubt in this one?
No, sir.
Sure. So if someone asks you what is the point source of wavefront will give, point source of light will always give me what type of wavefront? A spherical wavefront. Okay, sure. Now tell me the answer for this one. Like say for example, if a ray of light is being incident on a convex lens, this is what type of a lens? Convex lens. This is your principal axis. When the ray of light is being incident on the convex lens like this, what happened to the rays beta? They'll try to converge at one point. So this is your converging lens. It is acting as what? Converging lens. If someone asks you, when your convex lens, what type of wavefront we get? Now see, if I take the locus of all the points which are in the same state of vibration, and if I attach all of them like this, what type of wavefront we are getting? But it is a straight. So this one is called as what? Plane wavefront. It is called a plane wavefront. When a plane wavefront is been incident on your convex lens. Now here if I take your point like this, they are converging like this. So what we are getting? We are getting a converging spherical wavefront. We are getting a converging spherical wavefront. Am I clear with this question? If someone asks you when a ray of light is being incident on a convex lens, that means when a plane wavefront is incident on a convex lens, what is the output we are getting? We are getting a converging spherical wavefront. Am I clear? Am I clear?
Yes, sir.
Yes.
Sure. Now talk about your concave. If central part is very thin and outer part is thick, that is known as of your concave lens. When a ray of light is being incident on your concave lens, this one is your concave lens. Now, when the ray of light is being incident on your concave lens, this is your aperture of this one. The ray of light is being incident on this, it will diverge like this. And it also right now for me diverge like this. Now tell me what type of wavefront is been incident on this one. Again, if I attach all these source, so a line is being joined here. What type of wavefront it will be? A plane wavefront. This is your plane wavefront. Someone asked me what is when a plane wavefront is been incident on a concave lens. What type of a wavefront will be getting? It is going in outward direction like this. So this is giving me right now for me diverging spherical wavefront. Diverging spherical wavefront. Am I clear with this question? If a plane wavefront is incident on a concave lens, what type of wavefront we are getting? What type of wavefront we are getting? Diverging spherical wavefront. When a plane wavefront is incident on a convex lens, what type of your spherical wavefronts you are getting? Converging spherical wavefront. Am I clear? Sure. Tell me the answer for this one. If it is silvered outside, what will type of mirror it will be, beta? Anyone? This is your principal axis. This is your pole. If a mirror is silvered from outside, it is called as what type of mirror? A concave mirror. In a concave mirror, when a plane wavefront is being incident like this. So the ray of light after touching this one will reflect an incident on here. And here also after incidenting, it will reflect here right now and the image is formed somewhere here. Now tell me, when a plane wavefront, that means if I take this locus, and this locus, what type of wavefront has been incident on this one? A plane wavefront. A plane wavefront. When a plane wavefront is been incident on your concave mirror, what type of your wavefronts you are getting, beta? Anyone? We are getting your converging spherical wavefront. Now they are converging now. First this will form, next this one will form, this will form, and finally they will try to converge here. So what type of a wavefront we are getting again? Converging spherical wavefront. Am I clear? Am I clear?
Yes,
These are
sir.
all the questions so many times asked in the examination. Okay. Then if I'm taking your convex mirror is right now for me what beta? Silvered from where? Inside. So if it is silvered from your inside like this is your pole. When a ray of light is being incident on this one, when a ray of light is being incident on this one, tell me what happens. It will try to reflect here right now like this. And here also it is reflecting, right? That means when a plane wavefront is being incident on your convex mirror, this is a plane wavefront. This is your plane wavefront. What type of wavefront we are getting, but can you tell me? Because it will be converging. If I incident this one, the image is formed somewhere here, isn't it? So from here, the wavefronts are right now going in this direction, outward directions. The wavefronts are going in the outward direction like this one. So what type of wavefront we are getting? Can anyone? We are getting diverging, very good, diverging spherical wavefront. Diverging spherical wavefront. So I hope you are clear with the definition of a wavefront. So wavefront is nothing but locus of all the points which are in the same state of vibration. Locus of all particles which are in the same state of your vibration or in the same phase is called as of your wavefront. And every point of the wavefront will act as of what beta? Secondary source. They will act as of your secondary source. That is very important. Angle made by the wavefront with the ray of light is how much or more? 90 degrees. Now see, point source of light will give me what type of wavefront? Spherical wavefront. Convex lens will give me converging spherical wavefront. Concave lens will give me diverging spherical wavefront. Concave mirror will give me converging. Convex mirror will give me your diverging. This is what type of a mirror? This is your convex mirror. Am I clear? Any doubt in this one to anyone? If I'm talking about prism, any doubt, beta? Anyone? So this is a ray of light which has been incident on your prism like this. Okay. So if I take the locus of all the points, this point, exactly above that point, here 1 point, here 1 point. If I attach all of them like this. So this one is what for me? Your plane wavefront. If someone asks you in a question, when a plane wavefront is being incident on a prism, what type of a wavefront we get? Now see here, it will get like this ray. This ray will pass through this one also come like this one also will come like this one. This ray will also will come like this one. So if I attach all the points in the same state of vibration, and if I draw a line with this one, see, we are getting slightly bended. So we will be say that we will be getting your slanted plane wavefront. Someone asks you when a plane wavefront has been incident on a prism, what is an output we are getting? We are getting an output wavefront as what? Slanted plane wavefront. Am I clear with this one? Any doubt to anyone in this one?
No.
Clear, beta? Am I clear?
Yes, sir.
Sure. It's ready. Interference. What do you mean by interference, beta? Adding. When two or more waves are been adding at one point, like say this is a point, from here there is one wave coming, and from here there is one wave coming. This is your wave 1. This is your wave 2. When these two waves are coming and meeting at a point of your P, so point of P may be getting a maximum or minimum intensity. Am I clear? Two waves at your same position and at the same time. That is called as of your interference. I'll write here. Two waves meeting at same position. At same position. At same time. At same time. But phase difference may be different. That is called as of your interference. Am I clear? At interference, we may get a bright point. We may get a bright point or we may get a dark point. Like say in a room, if I on all the tube lights, we'll get a brighter point. If I off any one tube light, what is happening? The intensity will be reducing. Second one is also off. If all of them are off, then the intensity of that room will become for me 0. So at that time we'll be getting dark point. And if more than 2-3 tube lights have been on, the brightness will be increasing. So that points are called as of your bright point. Am I clear?
Yes.
Okay. Now see, first wave intensity is say for example I1. Second wave intensity is say for example I2. Amplitude of the first one is say for example A1. Amplitude of the second wave is right now for me A2. If both of them are meeting at this given point, we get a resultant intensity and amplitude. So resultant intensity is calculated by the formula I resultant will be equal to at a point P. This will be equal to your under root of your, if I'm writing square here right now, I'll write in terms of your IR. So this will be equal to your I resultant will be equal to your I1 plus of your I2 plus of your 2 times of your under root of your I1 under root of your I2 into cos of your phi. Phi is the angle between them. So angle between the two waves. So resultant intensity is equals to this much. And intensity is directly proportional to square of amplitude beta. So if I remove the proportionality constant, we get I is equals to K into your A square. So I resultant I can write in terms of your resultant amplitude. So A resultant will be equal to your, this will be equal to under root of your A1 square plus of your A2 square plus 2 times of your A1, A2 into your cos of your phi. So this will be the formula for your resultant intensity. So when two or more waves are meeting at a given point, the intensity can be calculated by the formula IR is equals to your I1 plus I2 plus 2 times of your root I1, I2 into your cos of your phi. Am I clear? And in the same way, resultant amplitude, A resultant is equals to your under root of your A1 square plus A2 square plus 2A1, A2 into your cos phi. And intensity is directly proportional to square of your amplitude. K is some constant. These are the formulas you need to remember. First formula is in the wave optics to do the problems. I resultant is equals to I1 plus I2 plus 2 root I1 root I2 into cos phi. Phi is the angle between these two beta. Angle between these two is represented by letter phi. Am I clear? Sure. Next one and very, very important. Relation between your path difference. Path difference is represented by delta x beta and phase difference. Phase difference is represented by delta phi. So if I'm talking about relation between path difference and phase difference. Relation between path difference and your phase difference, that is delta x and delta phi. Delta x and delta phi. Very, very important, but it is common for SHM also. So phase difference delta phi is equals to 2 pi by lambda into your path difference delta x. Very important formula. Delta phi is equals to 2 pi by lambda into your delta x. Am I clear? So what is the relation between the phase difference and path difference? Delta phi is equals to 2 pi by lambda into your delta x. In this one, see. For maximum points, for maxima, or we can call this one as bright point, or we call this one as constructive interference. Constructive interference. For maximum point or bright point, or for your constructive interference. Path difference will be delta x will be equal to n into lambda beta. Delta x is equals to n into lambda, when n value will be equal to 0, 1, 2, 3, 4, it may be anything. Okay. And phase difference will be delta phi will be equal to your 2 n into your pi, or 2 pi into your n I can write. 2 pi into your n. This will be the phase difference, delta phi. N value will be same again. N value is equals to 0, 1, 2, 3, 4, go. Am I clear? Per maximum, which is called as of your bright point or also called as constructive interference, delta x path difference is equals to n lambda and phase difference is equals to 2 pi into your n. Am I clear? And very important formula is what? Relation between them. Delta phi is equals to 2 pi by lambda into your delta x. Sure. I'm talking about the second point in this one. Per minima, which is also called as what? Dark point. For your dark point are also called as destructive interference. Destructive interference per minima, which is also called as of your dark point, are also called as of your destructive interference. For this one, the path difference is delta x. Delta x will be equal to your 2n minus 1 into lambda divided by 2. Very important formula. Path difference will be equal to 2n minus 1 into lambda by 2. The same way, phase difference delta phi will be equal to 2n minus 1 into your pi beta. This is your phase difference. We are having the proofs of all this one beta, but it is not necessary right now because you will be doing that one in intermediates. But for the competitive examinations, the direct results are very important. So for this value, n starts from your 1, 2, 3, 4, so on. Here also n starts from your 1, 2, 3, 4, so on. Am I clear? Am I clear?
Yes, sir.
So what is the path differences for, if I'm talking about for your minima, for minima point, which is also called as dark point or also called as of your destructive interference. For this one, delta x is equals to your 2n minus 1 into lambda by 2 and path phase difference will be equal to 2n minus 1 into your pi. Whereas here the n value starts from 1, 2, 3 but not from 0. Okay, in some books beta, it can also be written as 2n plus 1. If I'm taking plus 1, you start from 0. If I'm taking minus, you started from 0. You started from 1, sorry. Okay. Am I clear?
Yes.
Sure. We'll try to talk about maxima first. Tell me for first maxima. First maxima. Where do we get the first maxima? First maxima formula delta x is equals to n into lambda. Na? So n value how much will be taken? N is equals to, for first maxima, n is equals to 1. That means delta x will be equal to how much for me? Lambda. Am I clear? And what will be the value of delta phi? Phase difference. For first maxima, first maxima is formed at lambda. And delta phi will be equal to how much for me? 2 pi. For maxima, delta x is equal to n value starts from 0 now. So it is 2 pi into your n. N value is how much? I'll write with red pen. Delta phi will be equal to, delta phi is equals to 2 pi into n. And for minima, n value is equals to how much for me here? N value will start from your, sorry, this is also 0. No? So if it is 0 means delta phi value will become for me first value 0. And delta phi is also equal to your 0. Because in maxima, delta x is equals to the given condition. N value starts from 0. So if n is 0, first maxima is formed at your delta x is equals to 0. It is also called as of your central maxima. So where is the first maxima formed at the center? Where is the first path difference has been formed? At the center. Now tell me second maxima, anyone? Where is second maxima will be formed? Second maxima. Second maxima means n value is equal to how much for me? 1. So delta x will be equal to lambda and delta phi will be equal to 2 pi. Okay. So go on like that one. So I say that maximas are formed at 0, lambda, 2 lambda, 3 lambda, 4 lambda, so on. So, where is the part? Maximas are formed at what points, beta? 0, lambda, 2 lambda, 3 lambda, 4 lambda. And path difference have been formed at what positions? Anyone? Path difference. These are for path difference.
0, 2 pi.
Phase difference are formed at what positions, beta? 0, 2 pi. Next one is 4 pi. Next one is 6 pi. Sorry, 5 pi. So on like this. Am I clear? Hmm? Then beta, we also get 3 pi. Zero. First one is right now 2 pi. Next one is 2 pi n na beta. 2 pi into n. N value 1, n value 2. That means next one is 4 pi.
4 pi.
Then 2, the answer is right now for me. After 4 pi, it will be equal to 6 pi. Then 8 pi, so on like this one for phase difference. Am I clear?
Yes, sir.
Sure.
Yes, sir.
Done, beta. We give the
Yes.
heading for this one, maximum. Now tell me for minimum. Where is the first minima form? For first minima, n value, how much we are taking? For minima, delta x, n value is 1. First minima is formed at what position? Formula is 2n minus 1 into lambda by 2. So keep here 1. So it is 2 minus 1 is 1. So first is right now at your lambda by 2, first minima. The next one, 2 to the 4, 4 minus 1, 3. So this one is your 3 lambda by 2. Next one is 5 lambda by 2. Next one is 7 lambda by 2. Next one is 9 lambda by 2. Go on like this. Okay, path difference formula is so much better right now for me. What is the path difference formula we are written? 2n minus 1 into your pi. So it is 2n minus 1 into your pi. So now tell me, this is for path difference. Path difference. The next one, phase difference. You keep here n value 1. So it is 2. 2 minus 1 is 1. So it will be equal to your pi. Then you keep here 2. 2 to the 4. 4 minus 1. This will be equal to 3 pi. This will be 5 pi. Next one is 7 pi. Next one is 9 pi. So on like this one. This is for your phase difference. Am I clear?
Yes, sir.
So this is your per minimum. Okay. So here I'll write here, I'll rub this part here. Now tell me, for maxima, how do you calculate the amplitude? A max will be equal to, very important, A max will be equal to under root of your, this will be equal to A1 square plus of your A2 square plus 2 times of your A1, A2 into your angle between them is how much better right now for me? First one, 0, cos 0. Cos 0 is how much for me? 1, isn't it? Cos 0 is how much for me? 1. So A max will be equal to your under root of your, this value will become for me A1 square plus of your A2 square plus 2 times of A1 into your A2. That means A max will come out for me how much? A max will be equal to, this is your A1 plus of your A2. This is your A max. Okay. A max is equals to your A1 plus of your A2. Am I clear? Tell me what is A minima formula? I'll write here itself directly. A minima, minimum amplitude will be equal to A1 minus of your A2, direct formula. A1 minus of your A2, whichever is higher, that one should be taken as first. So it is A minima is equals to your A1 minus of A2. Now tell me what about the intensity? I max will be equal to, maximum intensity will be equal to root of your I1 plus root of your I2 whole square. Isn't it? In the formula, if I keep cos 0, so will be, this is the formula what you are getting, I max. So I max will be equal to how much for me? Root of your I1 plus root of your I2 whole square. Then I minima will be equal to how much better? Can anyone tell me? I minima, minimum intensity will be equal to your root of your I1 minus root of your I2. This one is right now for me whole square. This is your A minimum. Am I clear? So this is your A minimum. So you got the formula for A max and A minima and I max and I minima. Am I clear?
Yes, sir.
Sure. We'll take one problem here. See, if I say that you have got two beams of light. Two beams of light having intensities. Having intensities I and 4I. Okay. Interfere to produce a fringe pattern. To produce a fringe pattern on a screen. Okay. The phase difference between them is the phase difference. The phase difference between the beam is pi by 2. Okay. At point A and 2 pi at point B. At your point B. Then find out the difference between the resultant intensities. Resultant intensities at A and B. Good question. Come on, try it. I'm giving you the options. First option is 2I. Second option is 5I. Third option is 4I. And fourth option is I. So tell me. So try to do it out. We got two beams of light having the intensity is how much? So this is one beam, I. And this is your another beam. This is your 4I. Interfere to produce a fringe pattern on a screen. The phase difference between them is right now pi by 2 at point A. So this is your A. So intensity at point A will be equal to I1 plus of your I2 plus this is a 2 into root of your I1 root of your I2 into your cos phi. This is your formula. So IA will be equal to I1 is I, I2 is your 4i plus 2. This one is root of your I. This is root of your 4i into cos. Phase difference between them is pi by 2. Pi by 2 means how much beta? 90 degrees. Cos 90 is how much for me? 0. So that means this total term will become how much for me beta? 0. 0 multiplied with anything will be equal to 0. So intensity at your A will become how much beta? I plus 4i. This will be equal to 5i. Am I clear? Then again two waves are interfering at point B. This one is at point B. This is a one wave. This is your another wave. So here it is right now for me I. This one is of your 4i. But phase difference, here the phase difference was how much for me? Pi by 2. But here the phase difference is how much for me? Phi value is equals to 2 pi. So intensity at point B will be equal to I plus of your 4i plus 2 root of your I root of your 4i into cos of your 2 pi. Okay. Cos 2 pi will be equal to how much beta? 1, 360 degrees. So this value will become how much for me? I plus 4i is right now for me 5i plus this one is 2. This one is root I. This one is right now for me root of 4. That is nothing but equal to 2. This will be equal to 2. Am I clear? So root I into root I will be equal to how much beta? I na. So this one is your 2 into root of your I. Root I into root I is nothing but I. So it is 5i plus 2 to the 4. This is your 4i. So this will be equal to 9i. So intensity at your B will be equal to 9i. I was asking the ratio. Listen, what is asking the problem? Is it ratio or difference? The difference is asking, sorry. The difference between is asking. The difference between the intensities IA and IB. So that means IA minus of your IB. So here higher value minus of your lower value. So what is a higher value I can take? IB. Difference is asking, na? Just. So it is your IB minus of your IA. So it is 9i minus of your 5i. So that will be equal to how much value? 4i. So this is your answer. Am I clear? Am I clear with this problem? Just go through it once again. Any doubt in this one?
Yes.
Intensity at A when angle between them is 90 degrees. Intensity at B when angle between them is 2 pi. And the problem is asking the difference. He may also ask the ratio for that one. So at that time we can take the ratio, or is asking the difference. So IB minus IA, that will be equal to 4. Any doubt in this question? Sure. Keep a note and write these points better. First point. Interference follows law of conservation of energy. It follows your law of conservation of your energy. Point number 2. Average intensity will be equal to how much? How do you calculate the average intensity? I average will be equal to I max plus your I minima divided by 2. That means this value will be equal to I1 plus of your I2, or that will be equal to A1 square plus of your A2 square in terms of amplitude. A1 and A2 are amplitudes. And third one, this is very important. Intensity of light is directly proportional to, for doing numericals. Intensity is directly proportional to your width of slit. Width of slit is directly proportional to your amplitude, square of your amplitude. So I'll write here I is directly proportional to the width, and width is directly proportional to square of your amplitude. A is your amplitude width. Okay, so from this one I can write I1 divided by your I2 is equals to W1 divided by your W2, and that will be equal to your A1 square divided by your A2 square. So these are the ratios which you need to remember for doing the numericals when comparing your two waves. Okay. The next point also very important. Ratio of your I max divided by I minima. Just now we have derived it. I max value will be equal to. I max will be equal to how much for me? Root of your I1 plus root of your I2 whole square divided by this one is root of your I1 minus root of your I2 whole square. That in terms of amplitude, if I'm writing, it is A1 plus of your A2 divided by A1 minus of your A2. This is total whole square. So that means it will be written as of your A max divided by A minimum whole square. This will be the relations. Am I clear? And one more very important, fringe width. Fringe width. Fringe width represented by V. So fringe width is equals to, it is the difference of I max minus of your I minima divided by, this will be equal to your I max plus I minimum. Okay. If he is asking percentage, do it as 100%. So for I minimum, fringe visibility is how much better? Maximum. That means when both the slits have equal widths, fringe visibility is best and is equal to how much for me? 100%. Isn't it? See here. When I minima is equals to 0, then fringe visibility is maximum. Am I clear? When the fringe visibility is maximum, when I minima is equals to 0. When I minima is 0, fringe visibility is your maximum. In fringe width, what is the formula for the fringe width? Fringe width formula is V is equals to I max minus I minima into your 100. Am I clear? Sure. One more point in this one. Both the slits, when both the slits are of equal width of them are equal. Okay. The fringe visibility will be how much better? Theoretical question. The fringe visibility. Anyone? The fringe visibility is maximum. I can say it is your best. And equal to how much? 100%. And is equal to your 100%. Important point. Okay. So when both these slits are of equal width, both of width are same, then the fringe visibility is the best. And it is equal to how much for me? 100%. Am I clear? Am I clear? So interference follows what, beta? Interference follows your law of conservation of your energy. And average intensity is given by the formula I average is equals to I max plus I minima divided by 2, or it is I1 plus I2, or it is A1 square plus A2 square. And intensity is directly proportional to width, and that is directly proportional to square of your amplitude. That means if I'm writing the ratio I1 by your I2 is equals to W1 divided by W2. Am I clear? That means intensity is
Yes,
directly proportional to width, width is directly proportional to slit, slit is directly proportional to your square of your amplitude. Done? So in
the
tomorrow
last point.
class, we'll try to do the problems on interference, and we'll start with your coherent and non-coherent sources and YDSC experiment for doing the numericals. Am I clear? Am I audible, beta? Achara?
Yes, sir.
ఈ question answer చెప్పండి sir. Tell me the answer for this one question. Ratio of intensity of two waves is 25:1. Okay. If interference occurs, then ratio of then ratio of maximum and minimum intensity. Maximum and minimum intensity should be how much? Can anyone? Faster. We have got the ratio of what? Intensities. I max is asking ratio of your I max divided by your I minima. Intensity of waves is given how much for me? 25:1. So what is the formula I'll be writing right now here? Root of your I1 plus of your root of your I2 divided by, this one is root of your I1 minus root of your I2 whole square. So root of I1 is how much for me? Under root of your 25, isn't it? So it is your 25 times of your I naught plus this one is root of your I naught. I'll take it as 1 divided by this one is root of your 25 I naught minus root of your I naught. This is total whole square. So how much it will be, beta? Root 25 is right now for me 5 plus this will be 1 into your root of your I naught divided by this is 5 minus 1 into root of your I naught. I naught will get cancelled. This is to the power of your 2. This one is 6 divided by 4 whole square, isn't it? So 2 2s are 2 3s are. So it is a 3 by 2 whole square. 3 by 2 whole square means 3 square is 9 by 4. So 9:4 will be the answer. Am I clear? Am I clear?
Yes, sir.
Sure. So remaining problems, we'll try to do it in the tomorrow session of a class at 7:30. Problems on the interference, maxima and minima. Then we'll try to start with your YDS and its applications. Fringe width, dark point, 5 point, and problems when it is immersed in the water in different cases. Okay now? Sure. Take care, beta. Bye.